Hi, in this video I'll talk about the SAS proc and disc. Proc and disc is a canonical discriminant analysis procedure in SAS. It's used for dimension reduction for a huge number of variables. So what we mean by dimension reduction technique is that it is used to reduce a large number of variables into a small number of composite variables. Um, so what is a composite variable? It's nothing but a combination of the original variables. So what it does is that it finds the linear combination of the quantitative variables on the basis that the composite variables provide maximum separation between the classes. So it's a technique that is used in a dataset where you have some classification. It uses the Mahalanobis distance between the classes for separating the classes, and the technique is very much similar to the principal component analysis, wherein also we get a combination of variables to get the composite variables, which is instead used in place of the original variables. So finally what we get is the canonical component and the canonical weights. Canonical components can be used for further modeling exercises. For this illustration, I'll take a data set from the SAS cell, the iris data, which is very famous. We have this data is also used for cluster analysis and discriminant analysis. Just to show you the data set, it has got the different species, flower species, and their corresponding length, sepal width, petal length, and petal width. There are three categories in all. So those three flower categories and their corresponding width and length. Syntax is like this: proc and disc data, their input data. If you want to save, then I have to mention the dataset name. Distance, which compute the Mahalanobis distance, and ANOVA for comparison of the means. The class variable is species, of course, and the quantitative variables are sepal length, sepal width, petal length, and petal width. So when we run this, we will get an output like this, the initial statistics about the different variables, followed by the Mahalanobis distance, which says that how separable the two categories are. You can see the separation between Virginica and Setosa is 178, very significantly high, so quite different in that sense. Some univariate tastes, and then we'll get the canonical correlations. You can see there are two correlations significant here, the first and second. I guess after that all of them are insignificant. The first two are significant. Looking at the p-value, you can get to know. So the first one is of course very highly significant with 0.98 correlation, and the second one is 0.46. So the canonical correlations, as I said, talks about that how canonical variables are correlated with the original variables. So finally we'll have two canonical variables in place of four original variables. I know that's why we call it as a reduction technique, where we come down from four variables to two variables now. The canonical structure can be studied for grouping purposes, and also to see like how the original variables are correlated to the canonical variables and the strength of the relationship. So finally, what we'll be getting is that if you look at the output dataset, the output dataset is outcan. You can see it here. So you have the canonical variable 1 and canonical variable 2. The values, composite values. So in place of these original variables, we can actually use these canonical variables for the for any predictive modeling. We get the same kind of variables even in factor analysis, even in principal component analysis, the composite variables. So pretty much similar to that. Of course, we can there is some mathematical differences in terms of the estimation, where in principal component we maximize the total variance. Here the intention is to I mean the estimation is based on the the separation of means and variance between the classes. So that's the mathematical difference, but pretty much the use is same.